Hi, my name is Rodrigo Cedillo Corona. My ID is A01708287, and I am on the course of Analysis of Electrical Circuits, Group 301. So basically today I'm going to present you my oral presentation of this subject. Basically we have an electrical circuit. We have to use the supernode methodology to find a voltage. So here we have our circuit. As we can see here we have a supernode that indicates us that we have to use the supernode methodology. So the first step that I do is to define the direction of the currents and the nodes. Here we have our ground, so this will be B0 and B0. And here is our node A or BA and our node B or BB. And this is the voltage that we need to know. So first we define the direction of the currents. Here I have my current 1 that is getting out of the node. Here I have my current 2 that is getting out of the node. Here I have the current 3 that is defined already and is entering to the node. And my current 4 that is getting out of the node. So as we know, in our supernode, the voltage A, that is our node A, minus our node B, that is BB, it's equal to our assigned voltage, that is 7. So that be equal to BB equal to BA minus our voltage, that is 7. And for our BX, we know that is equal to our node A minus our B0, that is the ground. So it's basically equal to our BA. So we go to our KCL equation that the E3 is entering our minus our current 1 that is getting out, minus our current 2 that is also getting out, minus our current 4 that is also getting out. This is equal to 0. And this is equal to this, our current 1 plus our current 2 plus our current 4 equal to our current 3 that is already defined. So then we define our currents. As we can see in the current 1, we have the BA, that is our node A, minus the voltage 2 that is already defined, that is 5 voltage, divided by our resistance, that is 30. To our current 2, we have that is equal to BA minus B0, that is 0, divided by our resistance, that is 45. And we have our current 4, that is BB minus B0, that is the ground, divided by our defined resistance, that is 28. And this is equal to the current 3 that is already defined, that is 0.25. So as we know, to replace the BB, we have that BB is equal to BA minus 7, and we replace it here. And all this, in my case, I will multiply it by the largest number of the denominators, that is 45. So the next step is to group the terms, the voltage with the voltage, and the entire numbers with the entire numbers. And then we just divide our 30 by the 4.1, and we get our BA. And dividing this by this, I get that my BA is equal to 7.32. And as we said that BX is equal to BA, so our BX is equal to 7.32 voltage. So in order to see if our result is correct, in this equation we replace the BA with our getting value, and we have to get 0.25. And as we can see in our calculator, we get 0.25. That is the result that we want to see if our result is correct. So this indicates us that we are right. So that will be all for my part. Thank you very much.